And our last topic here in electrochemistry, and potentially the last video that we'll be watching this year, at least in terms of notes, not in terms of problems, because we have that coming up, is how we apply Faraday's law with electrolysis. So electrolytic cells drive a reaction. The electrons are a reactant, and the number of electrons have an important stoichiometric relationship with the chemicals in the reactions. A lot of times in stoichiometry, we're only focusing on the mass. Maybe we're only focusing on the volume of a gas. But here, we also need to think of it in terms of charge. One thing, and I chose silver, I'm going to change it here to copper for two reasons, is copper uses multiple electrons. So that helps us out in this example. But if I wanted to plate something with copper, what I would want to do is get copper ions to dissolve into solution at the anode from maybe a piece of pure copper. And then I would want those copper ions that are floating around in solution to be solidified back or turned back into solid. That would allow maybe some cheap metal spoon, something zinc or something else, to be plated with more expensive copper. This reaction gains and loses 2 electrons, 2 there and 2 there. So that means 1 mole of copper is plated for every 2 moles of electron that flow throughout the cell, which is why I changed from silver to copper right here. Understanding what that means, along with Faraday's constant, what current is, and all these other equations, allows us to do stoichiometry to think about how much copper we can produce. So a couple important definitions here is that current is defined as the amount of charge in coulombs per time. So that is given as I equals Q over T on the equation sheet. We can rearrange that or really think about the current times the time tells me how much charge has flowed. If I use Faraday's constant, I can connect the amount of charge to how many electrons have been used. So most of these problems are setting up a stoichiometry problem. So right here, we're thinking about how can I make a connection in terms of current to time to mass. So right here, we would think about, well, 25 minutes is a certain number of seconds. It's 25 times 60. During those 60 seconds, by definition, 4 coulombs flow every 1 second. That's what current is. So we've got our current there. Well, 96,485 coulombs of charge is present in every mole of electrons. 2 moles of electrons are required to produce 1 mole of copper solid, and every mole of copper solid is almost 64 grams. So when I run those 4 amps for 25 minutes, I'm able to plate about 2 grams of copper. So the key is the dimensional analysis, connecting the time to the current, connecting the current to the charge with Coulomb's law, the electrons to the element using the redox reaction. So here are 3 different examples of different things you could be asked or different ways you could set up a problem given mass, current, or time to solve for an unknown.